Hello, algebra students. Mr. Lawrence here with your next flipped lesson, and this is quadratic formula day 2. And today you're going to be able to say I can find the vertex of a quadratic equation using the formula x equals negative b over 2a. And that should look really familiar because we know that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, why I say it looks familiar is if you check this part right here out, I'm using just this part of the quadratic formula, negative b over 2a. See how they match? Yeah. I mean, if I really wanted to, I could rewrite this as two fractions. One of the fractions would be negative b over 2a, and then plus or minus square root of b squared minus 4ac all over 2a. So I could break that down into two. I'm not going to do that, but I'm just showing you that this is right here. Okay, now let's go down and remember, what is this used for? Well, we use this to find the roots, the zeros or solutions, which are the places where the parabola will cross the x-axis, right? Then we found the vertex by averaging the roots and substituting that value in for x. Okay, now we're not going to have to do the averaging anymore. So let me come down here and show you how to use this. First of all, I'm going to identify A, B, and C, and there's C, right? And so if I want to find the vertex, I'm going to do x equals negative b over 2a. So I'm going to take the negative 2, put it over 2a, and a is 1, and that's going to give me negative 2 over 2, which is negative 1. That is the x-coordinate of the vertex. All right, so to get the y-coordinate, I'm going to use a t-table. And so I'm going to plug in negative 1 for x, 2 times negative 1 minus 8. This, of course, is equal to y. I just plugged it into the equation right here for x. And we're going to get 1 minus 2 minus 8. Sorry, having a little parenthesis thing there. That's unnecessary. And then y is going to equal negative 9. So what this means is my vertex, my highest or my lowest point of my parabola, will be at the point negative 1, negative 9. It's going to be right there. All right. Now I can still go and use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a to go ahead and find out where the zeros actually are. So I'm going to do that. Well, I've got a negative b is going to be negative 2 plus or minus 2 squared minus 4 times 1 times negative 8. Whole thing is over 2 times 1. And I'm going to simplify that as best I can. So x is going to equal negative 2 plus or minus square root of 4 plus 32. I'm liking this one because it's going to come out pretty. X equals negative 2 plus or minus square root of 36 over 2. And that means that negative 2 plus or minus 6 over 2. And so I'm going to have two answers. I'm going to have negative 2 plus 6 over 2. X is going to equal 2. And I'm also going to have negative 2 minus 6 over 2. And x is going to equal negative 4 in the case. So I'm going to plot point at 2 and at 1, 2, 1, 2, 3, 4. There we go. So there are my zeros. And notice my parabola looks like it's smack dab in the middle. And then I can just draw my parabola. Okay, so I clone it and There we go. There's our parabola. Okay, let's check it out again here. Here's problem number 2. I'm going to identify A, B, and C. So we get 1, 5, and 6. And x equals the negative b over 2a. Going to find that vertex. So I'm going to get negative 5 over 2, which is going to be negative 2.5, right? So to get the y coordinate, I'm going to stick negative 2.5 in for x. So we get y equals negative 2.5 squared plus 5 times 2.5. I rewrote 2.5 as 5 halves, and you'll see why in a second. All right, so so this is going to be 6.25, and it'll be positive. And this is going to be 25 over 12. 24 over 12 would be 12, so 25 over 12 must be 12.5, and then a 6. And it looks like y is going to end up equaling negative 0.25, or negative 25 hundredths. Okay, so if I went to graph it, my vertex, see if I can move some of my work over here, just to get out of my way of the graph. Oops. Oh, I lost my minus. Okay. So, my vertex is going to be at negative 2.5, and then negative 1/4, so right about there. So negative 2.5, negative 0.25. All right, now I can use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I took a shortcut and just squared that right there. So if I simplify that, negative 5 plus or minus square root of 25 minus 24 over 2. So I'm going to get negative 5 plus or minus square root of 1 over 2. That's going to equal negative 5 plus 1 over 2 and negative 5 minus 1 over 2. All right, so I'm going to get x equals negative 2 and x equals negative 3. So there are my two zeros, or my roots, or solutions, there and there, and my parabola will look something like that. All right, let's see how we're doing on time here. Okay, not too bad. So let's go down here, identify A, B, and C, and I get A is 1, B is negative 6, and C is 9. So I'm going to go x equals the negative of b, notice the 6 change signs, over 2a, which means I'm going to get 3. So my vertex occurs when x is 3. So I'm going to take y equals 3 squared minus 6 times 3 plus 9, and that, my friends, is going to equal 0. That means that this vertex is sitting on the x-axis, and that's okay. That's okay. Now, if I go use the quadratic formula, it'd be an unnecessary step, because in this case, I'm just going to get 0 because I'm on the x-axis already. So the vertex is the answer to the quadratic formula. It's kind of an unusual circumstance, but it does happen. So how do I get my other 2 points? Well, I'm just going to use my t-table, and I'm going to plug 0 in. And if I plug 0 in for x, I put 0 here, here, and here. Won't I get a 9 out? That means 0, 9 is going to be on my graph. All right. Now, part of my parabola is going to look like this. or something like that, right? And I know that my parabola has to be symmetrical. So I'm going to use a little symmetry idea here to make the math real simple. I know my parabola has to do this. And doesn't it look like my graph is hitting right here at this point? Doesn't it? Sorry, I'm not sure why I changed color on that. I think I hit the wrong thing, but you get the idea. Now look, if I go 3 units to the left and then up 9 units, and parabolas are perfectly symmetrical, then if I go 3 units this way, I'd have to go up 9 units, right? So 0, 9 is on the graph. Well, what x value is 3 units on the other side of 3? 6. And therefore the y value is 9. And see, I didn't have to do any math. I didn't have to plug 6 in for x. Now I could. I'd get 36 minus 36 plus 9, and that equals 0. Oh, equals 9, excuse me. That equals 9. But I didn't have to do that because of symmetry. I only had to do one. Okay, one more example. And again, we're going to identify A, B, and C. And we're going to get 1, 4, and 8. And then we're going to use the first part of the quadratic formula. And we're going to have negative 4 over 2 times 1, which is negative 2. So in my t-table, my vertex is going to occur at negative 2. So I'm going to put in negative 2, and I'm going to get all right, plus 4 times negative 2 plus 8. And so I know that this is going to get me a negative 8, and those negative 8s are going to cancel. So I'm going to be left with a plain old 4. And so let me get that on the graph. So that's what, negative 2, 4, negative 2, 1, 2, 3, 4. Okay. Now I happen to know something that's going to happen with a quadratic formula in this one, but you don't know it, so let's go find out. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so when I simplify this, I get negative 4 plus or minus the square root 16 minus 32. You should have warning flags going off in your head. That should bother you. But let's keep going if it doesn't bother you yet. 16 minus 32 is negative 32. Do you know the square root of negative 32? Well, if you think you do, you don't. So, we do not know the square root of negative 32. This problem has no solution or no roots. That doesn't mean we can't do it. It means it doesn't cross the x-axis. Did you hear that, Jared? This means it does not cross the x-axis. Yeah, this parabola will not cross the x-axis. It's going to be a U-shape, but it's not going to cross the x-axis. It might go up like this. It might be over here. It might do a lot of things. It will not do this. No, 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 no. All right. So how are we going to get those other 2 points? Well, we're going to go to a t-table. And I like using 0 for x. So I'm going to put 0 in for x. And when I do, I get 0 plus 8. I get 8. So 0, 8 right there. Okay, and then you want to use symmetry. I'm going to go 2 this way, which means I'm going to put negative 4 in for x. Put negative 4 in for x, I'm going to get 8 out again. How do I know? Symmetry. Okay, and so then I can draw my parabola. And there we go. All right, so quickly recapping what we did. We took the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. And we use that whole thing to find roots, right? To find the roots, which are also called zeros or solutions. right? But then we know to find our vertex, we can just use this part of the quadratic formula. This will find me the vertex. Ooh, let's write in crayon. I've never written in crayon before. So x equals negative b over 2a. That gets me the x coordinate of the vertex. Looks kind of cool. Let me know if you couldn't read that because I won't do it again if you can't read it. All right, so there you go. That is it. Oh, but how do we get the y coordinate? Use, sorry, to get y, use a t-table. All right, that's it for tonight. Mr. Lawrence signing off. Good night, everybody.